Okay, today we're going to look at the ear model. And so this is our model in lab. And just to go over a few things, pretty basic. So we've got this outer part of the ear. Remember that it is elastic cartilage, able to change shape, bend, and come back. But this part is called the auricle. Another name for an auricle is the pinna. And so the auricle or pinna is this outer part of the ear. As it is all shaped, the design is to take pressure waves that are in the air and funnel them into this little tube. Now this tube, you might be tempted to call it the Q-tip canal, but that would not be correct. This is called the external acoustic meatus. Now there are different names for it as far as the three parts. The external is always the same. Acoustic is sometimes referred to as auditory, but I would be very careful of that because we're going to see that this is the auditory tube as well. Another thing is, instead of meatus, it can be called canal. Now, I personally, I've always learned it as the external acoustic meatus. But again, as long as you put them all together correctly, you could call it the external auditory meatus or external auditory canal or external acoustic canal. But again, my personal preference has always been external acoustic meatus. Now, this little canal, as the pressure waves come through, they're going to end hitting this little membrane right here. We commonly call it the eardrum, but that is not a correct term for it. This, which if you look at it, is quite like a speaker cone, only in reverse. This little speaker cone is called the tympanic membrane. So as the pressure waves go through get funneled by the auricle, go into the external acoustic meatus, and they bounce against this. And kind of like a speaker cone, only in reverse, instead of it vibrating to create pressure waves, it vibrates and it will move three bones that are going to be connected to it. The three bones, two of them are on this model, and I will kind of try to point them out. There is a little handhold thing there that kind of gets in the way. But the one that is on the tympanic membrane is the malleus. The malleus then connects to this one that sticks out called the incus. The malleus, the incus, and then the final one is on this part, and it's called the stapes. It looks like a little stirrup. Right? So the malleus, the incus, and the stapes, M-I-S, malleus, incus, and stapes. As I put this back in here, these would work together, and it would vibrate as the sound waves hit here. The malleus goes back and forth, causing the incus to go back and forth and causing the stapes to be pushed into this little cavity on this really amazing structure. So I'm going to pull it out. This structure here is going to have two very important parts, especially for us in lab. Now, the part that looks like a little snail shell here, this is called the cochlea. It is your hearing apparatus. So as the stapes pushes in and out, this whole structure is like an eggshell, right? And it's filled with a fluid, and there's a little oval or a little oval window underneath the stapes. So as the stapes pushes in and out, it's going to cause a pressure wave of this fluid to go around this cochlea up to the circle, the top, and then come back around, and then go out what is called the round window, which you see right here, because you have to have a way to get rid of the pressure of that fluid. But this is where our hearing apparatus is. And so this is called the cochlea. And off of the cochlea, you can see on our model, this represents cranial nerve 8, the vestibulocochlear nerve. It was at one time called the auditory or acoustic nerve. Those terms are no longer acceptable because it is more than just for hearing. And that's where we get these three little incomplete rings on this side. They're called the semicircular canals. The semicircular canals are for your balance. And so one part of your balance. And so this whole system sits here. get it in that little spot there, sorry. And so the stapes, again, looks like the little stirrup. As it gets moved in and out, it's going to cause this pressure wave in the fluid into the cochlea, causing neural transmissions to be sent on cranial nerve 8, the vestibulocochlear nerve. It is a sensory-only nerve. That means there's no information coming out. Again, vestibulocochlear. So this one's going to the cochlea. This one, this middle part, is called the vestibule, and the vestibule is going to be a big part in your balance. And again, a big part of that are the semicircular canals. Now, this area, so if I zoom back here again, so we've got this canal coming in here, this meatus. This area is a little cavity. And so we have pressure. So we have pressure in here that we need to make sure we keep equalized. So like, let's say right now I am at sea level and I get in my car and I drive a couple hours away into the mountains. The outside pressure will decrease, but this little cavity will still have pressure in it. So I'll feel this pressure in my head, and most of us have felt that. Now, there's two ways that can happen. Either I decrease or increase the pressure out here. One thing I will tell you for sure, because a lot of people that dive, which means I've increased the pressure here, which means that battle at my tympanic membrane has more pressure externally. They'll tell people to hold your nose and blow. I would highly recommend that nobody does that unless you are diving. Because the other way is if this pressure builds up in here and this is now lighter because we've gone up in elevation or I've had a decrease in pressure, this tube, which I will talk about now, called the auditory tube, this tube connects to your pharynx. This is the pressure valve to regulate the pressure in this cavity. That's why if you're going up in an airplane or whatever's happening where you feel that pressure build up, if you chew gum or yawn, all you're trying to do is stretch this little place here and it'll open up and the pressure from outside will equal out, and that helps. And so you'll have to continue to do it. But I would highly recommend not doing the hold your nose and blow thing. But anyway, this auditory tube is also called the eustachian tube. This is in children a lot of times. I don't know if they still do it or whatever, but when they're small, this tube is not angled, it's more parallel, and so fluid has a tendency to build in there and you get ear infections, and so they put tubes in the ears. So that is our overview of the ear model. I hope that helps, and have a wonderful day.